All right, so let's try a couple of these here. I'm going to start with this first one. F of x equals negative, and then it is 1 over, I'm pretty sure that's an x minus 5. This picture is a little bit small. Okay, if it's an x plus 5, I apologize. I'm pretty sure that's an x minus 5. So we got x minus 5 plus 2. Okay, so when I do these, I always start with the denominator. If the denominator equals 0, then that's a place where this graph cannot exist. They call this the asymptotes, and so it specifically would be called a vertical asymptote is a place where the x doesn't work. And so you can take this denominator of x minus 5, set it equal to 0 to solve. So I would add 5 to both sides, and I get x equals 5. Okay, so this is my vertical asymptote. Okay, so that means on the graph at 5, 1, 2, 3, 4, 5, there is an imaginary line going up here that the graph cannot exist on this line. Okay. Next, we want to see if there is a horizontal asymptote. So we look at the degree of the numerator and the denominator. The degree of the numerator would be 0. The degree of the denominator would be 1 because it's x to the first power. Since the degree of the numerator is smaller than the degree of the denominator, it would normally mean that it's just 0. But since we have this plus 2 afterwards, it's going to be 2. So y equals 2 is going to be my horizontal asymptote. Okay, so here we go, y equals 2. So on the y-axis at 2, now I'm not for sure the other things that your teacher would mean by key characteristics. I know that these would be 2 things. A lot of times they also ask for zeros of the function. Zeros are when this equals 0. So you can find zeros by setting this thing equal to 0. So I'm going to say 0 equals negative 1 over x minus 5 plus 2. So if I set it equal to 0 and then solve it, that would tell me a 0 of this function. And that's basically a place where this equals 0, where the y is 0. It's going to cross the x-axis, okay? So subtract 2 from both sides, and I get negative 2 equals, and this negative here I'm just going to put on the top with that 1, negative 1 over x minus 5. I would solve this by multiplying both sides by x minus 5. There's other ways to do that. So over here, these are going to cancel. Over here, that'll distribute, so I get negative 2x plus 10 equals, and on this side, I just have a negative 1. I'm going to subtract 10 from both sides. Get negative 2x equals negative 11. Divide by negative 2, and I get x equals a positive 11 halves. So that's what, 5.5 approximately. So at 5.5 so it would be written this way: x is, or I'm sorry, I just got myself confused for a second. So this would be where the y equals 0. So this would be 11 halves 0 would be one of the solutions or one of the zeros of this function. So 1.5 or 5.5 would be just past this right here. So now I'm going to tell you right now, I already know, just because this is in this little quadrant area, I know that this graph is probably going to look like this through there and head off that direction, which means over here it's going to be most likely here, heading up this way, because they usually look that way. You can also plug in some other numbers. You could find, you could set the x itself, plug in a 0 for the x to find where it crosses the y-axis. That might be another thing that you'd want, so you can put a 0 in. So let's see here. Okay, so we say y-intercept. So the y-intercept, and so that means I'm going to put a 0 in for the x, and so I'm going to say y equals negative 1 over 0 minus 5 plus 2. 0 that's negative 5. Negative 1/5, or negative 1 over negative 5 is a positive 1/5. So y equals positive 1/5 plus 2. So 2 1/5, basically. So we got this point as well. Then you can say 0 comma 2 1/5 would be and that makes sense, 1 2 1/5. Okay, so that was a little bit off right there. You can also plug in some random points just to make sure that it's right. I mean, you can plug in, and this is one of the things, you can always plug in an x number, find a y value that goes with it, and plot that point. That will work every single time, no matter what type of functions you're working with. You can always plug numbers in. Okay. So that's the first one. I hope that's helpful. I'll try to make a few more here in just a minute.